As we can see, PHP is taking the quick lead, but Python and Ruby are coming out of the gates. Here comes JavaScript. We seem to be having a little bit of trouble with JavaScript. Oh, it's a package conflict. C#, Java, and C++, they're not out yet. They're still writing the code, Here comes C# and Java. Oh, we got a late entrance. Swift. Swift's new language. Got all kinds of optimizations. They're still writing that C++ code. All right, it's compiled. Hey guys, in programming languages, you have three ways you can measure their speed. Just like in martial arts and fighting, there's a couple ways at least, and you could argue three ways you can measure speed. In fighting, the three ways, well, at least two, is the physiological speed, number one. That's the miles per hour speed in terms of how fast you can throw a punch or a kick or whatever. Then you have timing speed. Timing speed allows you to time your opponents properly, so even though you may not move as physically as fast as them, using timing speed, you could beat them to the punch, pun intended. And then there's tactical speed. By using tactics properly in a fight, you can actually maneuver more quickly and more efficiently than somebody who may actually have naturally faster hands than you. So there's three types of speed, yes. There's three types of speed in fighting. You got the physiological speed, you got the timing speed, and you got the tactical speed. Timing speed and tactical speed can be used to easily overcome somebody who's naturally, physiologically faster than you. All right, back to programming. In programming, there's three ways to look at the speed of the language. There's speed of writing it, how much code you need to write to actually get something to happen. So for example, Java, great language. I like the structure of it. It was my favorite language back in the day. It's a very verbose language, meaning you have to write a lot of code to get anything done versus, say, a more nimble language like JavaScript or PHP or Python or Ruby, Swift. Java is just a very long-winded language. That's why you see a lot of the Java work today is for legacy work, older work. They do it for Android, but now because Java is long-winded and verbose, people are now going to start looking at Kotlin for writing native apps for Android as opposed to using Java. Just like in the iOS world, Apple came up with Swift because Objective-C, which is the language that traditionally you would use to create iOS apps and macOS apps, a little long in the tooth, again, long-winded language, Java-esque, if you will. So speed of writing is a very important part, very important thing to consider when writing code. In fact, experienced developers will always tell you that they would prefer to use a nimbler language in terms of writing at write time, when you're writing it, that may be a little slower at runtime, we'll get into that in a second, versus doing the opposite. So that's why Kotlin, I don't know if it's good. Actually, it might run just as fast as Java when it compiles down. But we'll look at Python. Python in the AI world. A lot of top AI guys, they would write the core engine for an AI in C++, but then they would use Python to do everything else. So 5% of their application would be in C++. The rest is all in Python. Why? Because they said if they did it all in C++, it would take 800,000 years to complete. So again, writing time speed, if you will, is very, very, very important versus runtime. So you got write time speed, then you have deployment speed or ease of deployment, if you will. One of the reasons I dropped Java in the day, beyond the fact that it was a very verbose language, took 10,000 lines to do hello world, was that deployment was a real pain in the butt as well. It was, you had to compile, then you had to upload, you had to stop and start the app server. It was just a pain, especially if you're doing many deployments. Whereas with a nimble language like Python, PHP, because it's just, you know, it's not compiled, you just upload, done. It's running, right? PHP is a king, especially when it comes to web apps. PHP, if you want to get your PHP up and running, you just upload it, boom, it's done. It's pretty cool that way. So yeah, so you got writing speed, write time speed, you got deployment speed, and the final speed, of course, is runtime speed. How fast does the actual code run when it's actually running as a program or as an app? Java will run, of course, faster than Python or Ruby or PHP, and C++ code will run much faster than just about any other language, except for C maybe. You get the idea. So you got also runtime speed to consider. Now here's the great thing. Because computers and servers are getting so fast these days, like our smartphones today, like the average flagship smartphone, is far more powerful computer than a very powerful laptop from just 5 years ago, 4 years ago. So as time goes by, for most apps, runtime speed, the speed at which a code runs when the app is actually being used, is becoming less and less and less and less important. And in fact, for most apps these days, I would argue maybe 99% of apps, 98% of apps these days, runtime speed is really not too important because servers are just so fast and programming languages, even the slow ones, are so performant these days. So for me, when I look at languages in terms of the business perspective, I'm much more concerned about write time speed, meaning I rather use light, nimble languages at write time, and deployment speed, if you will, deployment ease, less concerned about runtime. No concern, I didn't say that, I didn't say there was no concern of runtime speed, but less concern because of the things I just mentioned. I hope this talk makes sense. Ciao, ciao.